Let's get into the veins that then drain blood back into the inferior or superior vena cava. So veins bring blood back to the heart. So if we start in the arms, we have a radial and ulnar veins named for their areas, just like I said, veins tend to have the same names as their artery counterpart. They drain into the brachial vein, which then drains into an axillary vein, well, actually, which then becomes an axillary vein. And the axillary vein then will move towards the heart, becoming the subclavian vein, and eventually the subclavian vein and the internal jugular vein come together and form the brachiocephalic vein. Brachiocephalic veins then come together, forming that superior vena cava. The cephalic vein drains the lateral aspect of the arm and empties into the axillary vein, and the basilic vein drains the medial aspect of the arm and empties into the brachial vein. There it is. So here you can see the radial and the ulnar veins that lead up into the brachial vein. They actually meet at a region known as the median cubital vein, which then drains into that brachial vein. Then the medial aspect of the arm is drained by the basilic vein. The lateral aspect is drained by the cephalic vein. Basilic vein drains into the brachial vein. The cephalic vein drains directly into the axillary vein. Axillary vein becomes the subclavian vein when the subclavian vein and the internal jugular vein come together. So here's the internal jugular vein. When they come together, they become the brachiocephalic vein, which then brachiocephalic veins, right and left, come together, forming that superior vena cava. And I just talked about this, but I'll say it again. Subclavian veins then receive blood from the arms via the axillary vein. And the vertebral veins drain the posterior aspect of the head, and the internal jugular vein drains the deep regions, the dural sinuses of the brain. And then external jugular vein drains the more superficial regions of the head and neck. And so here you can see, well, you don't really see, it's hard to see on these pictures, but there's dural venous sinuses that drain the main regions of the brain into the internal jugular vein. The internal jugular vein then eventually will drain into or will meet with the subclavian vein, forming the here's the internal jugular, I'm sorry. There's the dural venous sinuses which drain into the internal jugular. The internal jugular meets with the subclavian and becomes the brachiocephalic vein. Here you can see vertebral veins running along the vertebrae. There's an external jugular vein, which is not as thick as the internal jugular vein, but it drains the more superficial tissues of the head. You have a left and a right brachiocephalic vein that receive blood from the subclavian veins, the vertebral veins, and internal jugular veins. The brachiocephalic veins join to form the superior vena cava of the right atrium, or that runs into the right atrium of the heart. So let's look at the inferior vena cava then. We have anterior and posterior tibial veins, and we have fibular veins that drain into that drain into the popliteal vein, the femoral vein, and eventually the external iliac vein. The great saphenous vein, which is the longest vein of the body, receives superficial drainage. So it's going to receive from more superficial, not the deeper regions, which these are deeper veins here. This is for superficial drainage. Then each common iliac vein is formed by the union of the internal and external iliac vein. So here you can see that long great saphenous vein on each side, which takes in all the superficial blood. Here you can see an anterior and posterior tibial vein. Right there's the posterior, sorry. These drain into the popliteal vein, which drains into the femoral vein. Femoral vein leads to the external iliac vein. Here we have the internal iliac veins. Both external and internal come together, forming the common iliac vein, which drains directly into the inferior vena cava. The right gonadal vein drains the ovaries and testicles. Right, I say right. The left gonadal veins drains, so right gonadal veins drain the right ovary and right testicle in males. Left gonadal vein drains the left ovary and left testicle. And these empty into the renal veins. Left and right renal veins then drain the kidneys. We have a hepatic portal vein that drains digestive juices to the liver. And then we have a left and right hepatic vein that drain the liver itself, okay, that take the blood away from the liver. And so here you can see the renal veins. I don't think you see, because I'm looking, and I don't think that they are showing an actual gonadal vein. I don't know why they're not showing that. They talked about it, but they don't show it. You have a hepatic portal vein, which we'll talk about a portal system in a little bit, so you'll understand better. But basically, the portal vein takes the oxygen poor but nutrient-rich blood from the intestines and brings it to the liver. But then we have hepatic veins that drain the liver. So they take the oxygen poor, nutrient poor blood back to the inferior vena cava. We have the renal veins here and here that drain blood from the gonadal veins as well as the renal veins back into the inferior vena cava. We have the superior mesenteric vein and inferior mesenteric veins that drain back into the inferior vena cava. So let's now look at the brain, because the brain needs a really good blood supply. And if you leave the brain without oxygen for even a short period of time, it can cause damage, brain damage. So we have a really great protection. We have a special structure called the circle of Willis that helps to maintain not only blood flow, but also helps maintain pressure within the brain. So the internal carotid arteries divide into an anterior and middle cerebral arteries. These supply the majority of our cerebrum. Behind or in the back, we have vertebral arteries that join to form what we call a basilar artery. The basilar artery serves the brainstem and the cerebellum. So let's look at these structures. Here you have the middle cerebral artery, and here you have the anterior cerebral arteries. So these are feeding the majority of the cerebrum. Here's the basilar artery that feeds the brainstem and the cerebellum. Posterior cerebral arteries form a portion of the basilar artery, and these feed the posterior cerebrum, formed from the division of the basilar artery, and they feed a posterior cerebrum. So here you see the posterior cerebral artery that comes off of that basilar artery. So this is going to feed the posterior region of the cerebral hemisphere. Then we have special communicating arteries that take blood from the anterior to the posterior, and this forms a complete circle, and that circle is known as the cerebral arterial circle or the circle of Willis. So we have the anterior communicating and the posterior communicating arteries that help in forming this full circle called the circle of Willis. This allows blood flow in all areas of the cerebrum, and if there's any damage in one blood vessel, we have other mechanisms or other routes we can take to feed the brain still. And so this is just a picture of the blood flow in the brain. So very good blood flow. We have really good blood flow in the brain. The brain is highly vascular. So now let's talk about the hepatic portal. So I told you that we had this hepatic portal vein that drains the small intestines and takes that oxygen poor but nutrient rich blood to the liver. So a hepatic portal circulation is formed by those veins that drain the digestive organs, and then they empty into the hepatic portal vein, which carries the blood to the liver, where it can then be processed. All the nutrients can be taken out, and then the hepatic veins actually take blood from the liver and empty into the inferior vena cava. So we're not losing all of that extra nutrients. So any portal system is a system that contains two sets of capillary beds. So we have oxygen-rich blood coming in, going through this first portal system, where we're taking nutrients in, and there may be some toxins or other materials that are coming in, but then the blood is no longer considered oxygen rich. So it's oxygen poor, but it has a lot of nutrients. So these nutrients and potential toxins leave the capillary bed and move into the liver in the second capillary system. And then the blood leaves through a hepatic vein to the inferior vena cava. This keeps those nutrients in our system so we don't lose them all. And so this is a beautiful picture showing that hepatic portal system. So here we have superior mesenteric veins that are draining into this hepatic portal vein. The hepatic portal vein then moves into the liver, and up here we'll have hepatic veins that actually drain into the inferior vena cava. So at this point, you should be able to tell me major arteries and veins of the body, what the circle of Willis is, and what the hepatic portal circulation is. So I'm going to stop this video now, and I'll start the next video in a few minutes, okay? Bye.